Okay, so we are going to summarize quantitative data with numbers. So we're learning today about the range, standard deviation. That's kind of a big one, and one you might not be as familiar with. And then IQR is also something new. That's easy. The standard deviation is a little bit tougher, but the calculator is going to do most of the heavy lifting for us. Appropriate measures for center and variability to summarize a distribution of quantitative data. Okay, be able to describe how the shape and center of a distribution is a great start. However, two distributions have the same shape and center look quite different. Oh, that's interesting. Okay, so these two have the same center, right? The center looks to be about 600 to me, but much less variation. So the range would be much smaller for set A than set B, and they do have a different look to them because of that difference, I would say. Yeah, I mean, the shape is, they're symmetric, roughly symmetric, but that's about it. There are several ways to measure variability. The simplest is definitely the range, so I would agree with that. The range is the biggest minus the smallest. It's probably something you knew, honestly. It's a single number. Sometimes students will put both numbers and not actually subtract them, and that's not a thing. That's like the variability is between this and this, but range is one number. It's the maximum minus the minimum. Okay, Love Consumer Reports. They reviewed, and rated 14 different cars, SUVs. Here are the distances each vehicle needed to come to a complete stop from a speed of 60 miles per hour. So those are the distances measured in feet, I believe. Find the range of the distribution. So you would take the biggest number minus the smallest number. Looks like 149 and 126. So you would subtract the two and you would get 23. It's good to include the units there. Again, we want to include the context here, so get in the habit of including the units. Is a range a resistant measure of variability? It is not. Think about it. It's the biggest minus the smallest. If we had an outlier and the outlier was 200, like now the range is much, much bigger, right? So it is not resistant, just like the mean is not resistant. Why is the range not an ideal way of measuring variability? It just tells us 2 points, right? It doesn't tell us about all the data in between. So just the minimum and maximum, it's a really rough gauge, but we can do better, I think. How far, we want to find out how far, like the typical value falls from the mean. So that's more of a standard deviation there. You can see these have the same range, the same center, but one has a lot more variability to it. B is much more, the values typically are far away from the mean, whereas A, the values typically are pretty close to the mean. So they would have equal range, but more variability for sure in the second set there. If we use mean, I kind of mentioned this the other day, then we're going to use standard deviation. If we use median, we're going to use IQR. We're going to learn that today. Standard deviation is this complicated formula. It's the square root of the sum of the differences in the x values squared, and then divide by n minus 1. So it's like a whole big formula. I might derive it, kind of like use it to solve it by hand, just so you see what's happening there. I might use my calculator to do that. But you don't normally the calculator is going to crunch the numbers for you, typically for standard deviation. So when loose granular material like sand or asphalt is piled on the ground, the side of the pile forms an angle with the ground, okay, called the angle of repose. Each material has its own angle of repose. Oh, that's interesting. Kind of like when you drop sand on top of each other, it has a certain angle to it, but different materials, I guess, would be different. They're shown here. Okay, so there you go. Some kind of stack up higher, like steeper, and some kind of are not as steep. Calculate the sample standard deviation, interpret this value. I like it's kind of a small set. So I'm going to do this by hand here. So I'm going to go, I'm going to add a page, so Control Doc, and go to List and Spreadsheets. This is for repose. Repose numbers are 33, 45, 48, 50, 45, and 30. I'm going to go back to a previous page here so you can see the formula. See that formula on the right? I'm referring to that formula here. So I'm going to do a bunch of things here. So the first thing I'm going to do is find I'm going to call this diff. So this column is going to be called difference. It's the difference. I'm going to type in equals bar. You don't have to know how to do this, by the way. I'm just showing you so we can calculate this. So we want to find the difference of repose minus the mean of repose. So that's what the formula says. You take each x value and subtract the mean. So, wow, I guess I got fractions. That's surprising, but okay, I'm fine with that. It doesn't really matter. So the mean, in case you're wondering, the mean of repose is 77 divided by 2, just in case you were curious. So it's 33 minus 77 over 2. That gets that first number. 45 minus 77 over 2 gives you 13 halves. 28 minus 77 over 2. We're subtracting that mean over and over again until we have all of them. So we've done the first little part there. Now we want to square all of those values. So I'm going to call this SQ for square. And I'm going to put an equal sign here, and I'm going to say diff squared. Does that work? So I squared all those values. Still, they're fractions. That's okay. Now I want to, the sigma there means sum up all of those differences of the squares. So I'm going to go to a calculator page for this, control doc. Calculator, I'm going to say sum of, I think call that SQ for squares. Is that, let me give the decimal equivalent there. That might make more sense. 429.5 is the sum of all the squares. I'm going to divide that. So 429.5 divided by n minus 1. So n in this case, I didn't really look at it. Let's see. There are 1, 2, 3, 4, 5, 6 things. So n is 6. So let me go back to the formula so you can see it. So I'm going to say 6 minus 1, or 5 down there. That gives me that. And now I want to take the square root of that guy. Phew. I got 9.268. So 9.268, I think, might be the standard deviation of that. So let's do one variable stats because it'll crunch the numbers and do this for us, which is what you'll do on the AP. Menu 611 if they don't give it to you. I want this for not the crab, I want repose. So if you look at standard deviation, so sample standard deviation, SX there is sample standard deviation. We took a sample. And so that's 9.26822. I think that's exactly what we just got a minute ago. 9.26823. They rounded. But yeah, same number. Very nice. Okay, so that means, and I almost want you to know this wording for standard deviation. That is the typical difference from the mean. So they did kind of what I did here. They squared it. They added them, square rooted it, got that. The angle of repose typically varies from the mean by about 9.27 degrees. So that typical variation from the mean, or typical difference from the mean, is how I want you to say this. When they say interpret, they say use the definition of standard deviation. What is standard deviation? It's the typical difference or deviation from the mean, typical variation from the mean. So typically, these values vary from the mean by about 9.27 degrees. The notation S refers to the sample standard deviation. We mentioned that. I mentioned that when I said SX is sample standard deviation. The Greek letter, of course, is for the population standard deviation. Parameters are usually Greek letters. S is always greater than or equal to 0. I guess that's true. S equals 0 only when there's no variability. That is, when all values are the same. So if they were all the same, I guess it could be 0. Greater variation means the results are larger values of S. That's true. S is not resistant, right? So if you have a value that's way away from the mean, it makes sense that the typical difference or deviation from the mean is going to go up, in some cases way up, from one extreme value. So S measures variation about the mean. It should only be used when the mean is chosen as measure of center. So mean and standard deviation go together hand in hand. Median and IQR go together hand in hand. Oh, we're about to learn about IQR. Here we are. We can avoid the impact of extreme values by using IQR. So when the data is skewed one way or the other, definitely we're going to use them. We're going to use IQR, which is a simple formula. You just find the first quartile, the third quartile. We'll show you how to do that in a second. So this is what they mean. So let's say you have this many data values here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 data values. So if you put the median is going to be right between the 6th and the 7th term there. So 28.5 would be the median. So now I've broken the data values into groups of 6 and 6. So now if you look at the lower half here, there's 6 terms. The middle would be between 22 and 25 there. That would be the quartile one, or 25% point. Think of quarter like a quartile like a quarter, like 25%. If you look at the top half of the data, those 6 numbers, the middle is going to be between 31 and 34. That's the third quartile, or 75% point. So now, actually, you can see it. There's 3, 3, 3, 3. We split the data exactly into 4 equal parts. 25%, 25%, 25%, 25%. Quartiles can be used to describe the position. Okay, that's true. The formula for IQR, I kind of mentioned it, but it's Q3 minus Q1. So it's what we call the middle 50% of the data. It's kind of the typical data value would fall in there. So it's the range of the middle half of the data is kind of what it is. If you were like, how could I say it in words? Yeah, it's a formula, Q3 minus Q1, but in this case, it'd be 31 minus 25 would be 6. That's how long that when we do a box plot, that's how long the box is there. Catamarans are boats built with 2 hulls. They're very stable because they have a broad beam width between. Even some of them can go into the ocean. One important characteristic of these boats is the freshwater capacity measured in gallons to accommodate daily water use by those on board. Here are freshwater capabilities, a sample of 19 ocean-going catamarans. Okay, so we measured that. Finally, IQR. So you would need to, by the way, did you notice, I didn't mention this, but did you notice when you looked at our results here, if you look at the bottom, the 5 number summary, min, Q1, median, Q3. So it does give you those Q3 and Q1 values you need to find this if you do one variable stats. So we could definitely type this in and do one variable stats and find the IQR that way. I have a feeling they're going to do it by hand. They have to put them in order. It's kind of a pain, but if you do that, that's not too bad. So there are 19. So there's one term in the middle. To find the middle term when there's 19, I do this. 19 divided by 2, get a decimal. So that's 9.5. So round up, we need the 10th term. So I'm going to count to the 10th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 158.5 must be the middle term because it's the 10th term. There's 9 on each side there, and that would be it. So 158.5. Again, we could have done this one variable stats. And now, because it's the one number in the middle, it's actually all the 9 numbers below that are the bottom half of the data. So if you wanted Q1, you would find the middle of the bottom half. And same thing for the Q3, you would find the middle top half. Notice when there's one number in the middle, it is not included in either half. It's just the number in the middle. Whereas if there's 2 numbers in half, we actually include one on each side there. Notice they put the unit, gallons of water. Very good. How should we interpret the interquartile range from the example 3? So, okay, the middle half of the distribution of freshwater capacity of these 19 ocean-going catamarans has a range of 61 gallons of water. So the middle half of the data, the range of the middle half of the data, the middle 50%. Quartiles and interquartile range are resistant, robust, because they are not affected by a few extreme outliers. That's interesting. So medians are robust. They're not resistant. They are resistant, I should say. They are resistant. They're robust. So medians and IQR are used when it's skewed because they're resistant. Both of those measures are resistant, so we really prefer to use them when the data is skewed, when there could be an extreme value there. See that 400 right there? That looks like an outlier. So using the IQR here is huge. It's going to be the better measure of center. I don't want to use standard deviation here when it's skewed like that. I'm going to use IQR. Be sure to leave. I mentioned that already. And if it's one term, if it's two terms, you just kind of cut it in the middle. Depends on the shape. So this is what they're saying. What measures of center are resistant? So median and IQR are both resistant. So when the data is skewed, we're going to use those. Which measures are affected by outliers? Well, mean and standard deviation. So we're going to use that only when the data is roughly symmetric. This is what it's saying here. If it's roughly symmetric, mean and standard deviation all day long. If it's skewed, IQR or median all day long. We recommend to use the range to measure the variability only as a last resort. I kind of like that because it gives so little information. Sometimes we don't know the data value, so we just have to use the range, and that's okay. According to recent estimates, approximately 20,000 black bears live in Pennsylvania. Here are the summary statistics and a relative frequency histogram of the lengths in inches of a sample of 97 Pennsylvania black bears. Okay, there you go. There's some black bears. These are the lengths and the relative frequencies, how often those lengths occur. That looks roughly symmetric, right? So I would use the mean and the standard deviation here for measures of center. The distribution of the lengths of these 97 bears is approximately symmetric in mound shapes, so there's no apparent outliers. Therefore, we will use the mean and the measure of center and the standard deviation as a measure of the variability or the spread of the data. All right, that's the lesson for today.